Hello physics fans, here is a quite difficult projectile motion question for IB Physics Unit A1. Wile Coyote, in an act of sheer daring, is going to launch himself at an angle of 15 degrees to the horizontal at a velocity of 65 meters per second in his bid to catch Roadrunner. When he is on the cliff is 250 meters high and Roadrunner's is only 200 meters high. The question is, show that the horizontal displacement, in other words, his range from where he is horizontally to where Roadrunner is, how far away will he land? This problem is quite difficult and involves calculating really how long is he in the air for. So if you want to try and solve it, pause the video now and crack on. Otherwise, here we go. So in terms of his flight path, I think with any projectile motion it always helps to draw things like this clearly. So he's obviously going at an angle at 65 meters a second and 15 degrees. So we need to resolve the vectors vertically and horizontally. So for, let's call this uy and ux. So if we want to figure out that, it's going to involve a little bit of trigonometry. So uy will be equal to sine 15 multiplied by 65, whereas ux will be cos 15 degrees multiplied by 65. That's because we've got the hypotenuse up above, that's 65. Opposite the angle we have uy, so that would be the opposite side over there. And then the adjacent side would be ux. So as per SOHCAHTOA, we're going to use opposite and hypotenuse and sine. So when I punch that into my calculator, sine 15 multiplied by 65, I get 16.8 meters a second vertically. And I get, if I type in cos 15, I get 62.8 meters per second horizontally. So there we have our vertical and our horizontal components. Now, at this point, we probably want to start off some sort of SUVAT table so that we can figure out all the quantities that we want to keep track of. So initially, I'm only going to worry about the vertical. So we know that the initial vertical velocity is 16.8. If I assume that at the top here of his arc, the top of the parabola, his final velocity for a second is 0, because if it's going up, it's going to be a positive value, but on the way back down being negative in this direction. So for example, acceleration due to gravity is minus 9.81 meters per second. Then it's going to have to go through 0, positive, 0, negative. So that gives us one more value. Acceleration acting down the way, and there we go. So that's really step one in figuring out how long it takes to go up. So if you look at your equations of motion, there's one that fits quite nicely. So that would be 0 minus 16.8 divided by minus 9.8, and that gives us a time up of, let's do 16.8 divided by 9.8. That gives us a time up of 1.71 seconds. Now, time up is going to be shorter than time down because he's got all this extra distance to fall here, which is a total of 50 meters. So in order to figure out the time down, what we're going to need to do is go from as if Wile Coyote's falling from this height here. So what is that height? Well, we got to figure out SY now. Okay, we've got time up as 1.71. So what we're going to do is we're going to do S equals V squared minus U squared over 2A. All that is one of the equations of motion rearranged. S is the subject. So that's 0 take away 16.8 squared divided by 2 times negative 9.8. So let's see what that is for his peak height. So 16.8 squared divided by gives us 14.4 meters is how far up he goes from his starting point. So that would be this distance in purple here. Now, in order to fall back down, he's going to fall a total of 14.4 meters plus an extra 50 meters. So a total of 64.4 meters is how far he falls. Okay, now I'm going to clear up a little bit of room up top by getting rid of the green equations here. So just to recap there, we know that he's going to fall down the way 64.4 meters. We know that his time up was 1.61. Let's figure out his time down. So we're going to use S equals ut plus a half at squared here. And if Wile Coyote is falling from his peak there, his initial velocity is 0. So this term cancels. So this leaves us with S equals half at squared. This can be rearranged to give us t equals square root of 2s over a, or rather the square root of 2 times 64.4 over, let's try that again, 64.4 over 9.8. That gives us a time to fall, so the time down the way, of 3.62 seconds. Okay. Now that we know the total time in the air, which is a combination of this time in yellow and this time here, we know that Wile Coyote's initial speed, I've actually rubbed it out, but let's just get ux back in the go here. Ux was 62.8 meters per second. If we know that the total time that the Wile Coyote spends in the air, then we can just use displacement equals velocity times time. So his total displacement, here's our final answer, will be 62.8 multiplied by the total time, which was 5.3 seconds, 5.33. That gives us a total distance. Let's have it nice and big and black up here. The total distance we got here was 334 meters to 3 significant figures, which is about 330 meters. Done. There we go.